Wakanda forever!
Black Panther's suit has proven useful to Black Panther in several Marvel Cinematic Universe scenes, ranging from Black Panther to Infinity War to Endgame. But how does it work? And do the scenes explaining it work with the functionality shown in other scenes? The scene we're going to be considering is the scene in Black Panther where Shuri and T'Challa test out his new suit for the first time.
The entire suit sits within the teeth of the necklace. Strike it.
Anyway.
Not that hard, genius!
You told me to strike it. You didn't say how hard.
I invite you to my lab, and you just kick things around.
Well, maybe you should make it a little stronger. Hey, wait a minute.
The nanites absorb the kinetic energy and hold it in place for redistribution.
Very nice.
Strike it again in the same spot.
You're recording.
For research purposes.
Delete that footage.
My question was, how fast did T'Challa kick the suit in this scene in order to cause the effects that follow it? And is this possible with the current knowledge of Black Panther's abilities? I used the basic idea that the kinetic energy of the suit flying backwards plus the kinetic energy of T'Challa flying backwards should be equal to the kinetic energy of his kick, because when he kicked, some of that kinetic energy was put into the suit itself in spring potential energy, and the rest was put into the motion of the suit itself. If we make the assumption that all the spring potential energy stored in the suit is converted to kinetic energy when it thrusts T'Challa back, adding these two kinetic energy values should give us the kinetic energy value for his kick. Then, using the mass of the average foot, we can find the velocity of his kick. To find the kinetic energy of the suit moving backwards, I first needed to find the velocity of its motion. To do this, I counted the number of frames from the instant that he kicked it to this very moment. Then, using Chadwick Boseman's leg length, the actor for Black Panther, I counted the number of legs that the suit moved. I was able to deduce that the suit moved back 1.9512 meters in 5 frames, or 0.2083 seconds. Therefore, its velocity is 9.367 meters per second. My original plan was to look up the density of vibranium, calculated through Captain America's shield in prior films, and use that to find the weight of Black Panther's suit through its volume, but his suit is a blend of vibranium and an unknown amount of other materials, so the online consensus is that his suit weighs around 10 pounds. If we add the average weight of a mannequin that size, 20 pounds, we get a total weight of 30 pounds or 13.6 kilograms. Thus, its kinetic energy is 0.5 times 13.6 times 9.367 squared, because kinetic energy is 1/2 mv squared. My next step was to find the kinetic energy that T'Challa had while flying backwards. To do this, I first found the distance he moved backwards through a similar method, except when using Shuri's height for the y velocity component and his foot size for the x velocity component. Through counting the number of frames it took to reach this moment, I was able to find that his velocity was about 10.4911 meters per second. Therefore, his kinetic energy is 0.5 times 87.54 times 10.4911 squared equals 4,817.47 joules. If we add these two joule values together, we end up with 5,414.11. We can set that equal to 0.5 times 15.4 kilograms, which is the weight of the average leg or foot, times v squared. Then we can solve for v, ending up with a grand total and a final value of 26.5166 meters per second. This is about 59 miles per hour, which is fast for a kick, but isn't unheard of. Ronaldo, the soccer player, has been recorded to kick balls at 80 miles per hour. The scene and the speed at which Black Panther kicks is feasible, and the movement of him in the suit align up with the math. Thanks for watching.